I think we could probably get started. So thank you all for joining today. Today we're going to talk to you about how you can monitor data quality in Unity Catalog with SODA. So I'll be your primary host for today. My name is Tyler Adkins. I'm a customer engineer at SODA. I also have with me Raja from Databricks. And so he can start off with a little introduction about how Databricks works. But first, let's talk about some logistics. So we'll be recording this webinar and we'll share the recording afterwards. Also, I've prepared some examples in this webinar, and any of the code or artifacts for those examples, I'll put into a Git repository, which we can share at the end of the webinar as well. We'll also do a Q&A session at the end. So if you have any questions, you can feel free to put them into the chat, or there may even be a dedicated Q&A widget within Zoom that you can use. But we'll have Anton monitor that, and at the end, we can go through those questions. All right. Okay, so for the agenda for today, start first with kind of high-level introductions. Introduction to Databricks, which Raja will help with. And then I'll kind of give an introduction to SODA. What is SODA? How does it work? Next, we'll talk about how to connect SODA to Databricks. There's a couple different ways, both of which are pretty easy. Then I'll talk about how to define and run data contracts within SODA. And data contracts are going to be the place where all of your data quality rules live. And then finally, we'll talk about how to view and act upon the data quality results, which are going to be fed back into Databricks. Right. So first, we'll start with an introduction to Databricks, and I'll hand it off to Raja to go through one slide here.
Hey, everybody. Thank you for joining. My name is Raja Parimal, and I am an ISV Alliances Director at Databricks, focused on helping customers understand how to work with our data governance ecosystem to make sure that they're getting real and clear customer value out of their investments into the data intelligence platform. And Tyler is going to talk deeply about how SODA can help you. But I want to set some basic foundations about Databricks itself to understand why this is so important. Over the last 2 years, 3 years or so, we have evolved our platform to not just be a data lake or a lakehouse or even a data warehouse, but a comprehensive data intelligence platform that allows you to store your data in a public cloud in the format of your choice. That's why we see Delta Lake and Iceberg down below. We can then make sure that there is governance applied across all of that data with Unity Catalog, which SODA does integrate with. And then from there, you can use Databricks for any one of our multiple workloads. The ones that we have highlighted prominently are Lakeflow, which is what we use for ingestion, ETL, and streaming use cases. DB SQL, which is the way that our SQL analysts can interact with your data, and then Lakebase, which allows us to do applications that have write-intensive capabilities with your data. Undergirding all of that is Agentbricks, which lets make sure that your Databricks environment is running optimally and that you can then create AI use cases all on your own. With that, now that we have that basic foundational understanding of what the Databricks platform looks like, I'll toss it back to Tyler so he can describe how to make sure the data in Databricks looks the way you want it to.
Great. Thanks, Raja. All right, so let me just give a quick high-level introduction to SODA. So SODA is an end-to-end data quality platform, and it's going to help you find data quality issues, understand them, prioritize them, and ultimately fix them, even at the record level. So SODA overall is very highly integrated, very flexible, very lightweight, easy to use, easy to deploy. It's a kind of a hybrid operating model. So there's a cloud component, which is our UI, and that's kind of a control plane. But then the components that are going to execute these data quality scans, connect to your data, those components will be installed typically within the customer's private cloud. In terms of data sources, we can connect to any data warehouses, SQL databases, even data frames, so you can work with file-based data, API data, et cetera. So in the context of Databricks, we can connect through the SQL warehouse. We can also connect directly to Spark sessions, so you can work with data frames. In terms of orchestration, it's super easy to embed data quality scans within to any of your pipelines and workflows because we offer REST APIs and Python SDKs for triggering those scans. And I'll show some examples of how to do that in Databricks today. From a security standpoint, so does SOC 2 Type 2 compliance, supports single sign-on, role-based access. And It can integrate with any of your other tools like metadata catalogs, BI tools for dashboarding, visualization, and reporting, as well as communications and ticketing platforms like Slack and Jira and ServiceNow and so on. All right, so let's talk about how SOTA can connect to Databricks. So as I mentioned, the first way is through the SQL warehouse. Um, One nice thing about this is that you can do it all through the UI, so you don't have to write any code, you don't have to do any programming. You can just come into the SOTA Cloud UI, pick your SOTA agent you want to use, which is typically installed within your private cloud, and then you put in some secrets to connect to the SQL warehouse, and then from there on out, you can do everything through the UI in a self-service manner. The other way is using our Python SDK. You can connect directly to the Spark session. So if you prefer to do things programmatically within your, for example, your Databricks notebooks, you can do that with just a couple lines of Python code here. So Databricks always provides that Spark session, so you can create a Spark data source within SOTA using that Spark session, and then any of the views or tables within that Spark session will be available, so you can scan them for data quality issues. All right. Next, I'll talk about how to define and run a data contract within SOTA. So we'll start first with how to define a data contract. And I guess even before that, I want to talk first about what is a data contract. So um, within SOTA, a data contract is a formal agreement between the producers and the consumers of a piece of data. And that agreement will include all of the requirements or expectations for what that data should look like. So it's kind of a normative statement about what the data ought to look like. Um, and it's not just a piece of documentation, it's really an executable program. So you can actually test your data and see whether it's meeting all the requirements that are represented in that contract. So one way to get started is with our contract template library, which you can find on our website. And this is going to include a lot of useful examples for common data quality rules that show up in different industries. So if you're kind of just getting started out in your data quality journey, this is a great place to start to get some inspiration. And you can easily adapt these templates to work for your specific data sets. The other way to get started is using the observability metrics and results that SOTA collects. So before you even create a single data quality rule or a contract or anything, SOTA is going to profile your data and look for any anomalies in the evolution of the data over time. And this can be a great place to get some ideas for some data quality rules you might want to create. So it's kind of like going from a descriptive report about what your data actually looks like into a normative kind of contract about what your data ought to look like. So for example, you can catch things like, let's see, if we go into this example, I've got a finance loans table. I can see some profiling results. So right away, this is just a snapshot of what this data looks like today. I can see there's some missing data, maybe some duplicate data. I can see maybe there's some outliers or some invalid data in some of the columns. So I can go from here to immediately start creating some data quality rules to catch these issues proactively and help me kind of enforce improved quality for my data. Similarly, we have metrics monitoring, which is kind of like profiling, but looking at how those metrics are changing over time and then trying to detect anomalies just in a statistical sense. So any anomalies in the volume of data, the schema, freshness, et cetera, would just be caught out of the box. But also any other fields that you want to monitor, you can look for anomalies there. So like I've got this loan amount average metric monitor, and it's catching some kind of outliers on specific days. So maybe I want to create a rule that puts a fixed threshold to let me know if those outliers happen. So it's just kind of explaining how we can go from observations about what the data looks like to expectations about what it ought to look like. And in fact, later this month, we're going to release a new feature, which is going to fully automate that process. So it's going to go automatically from the profiling and metrics monitoring, sampling data results to a suggestion for what the contract ought to look like. In the meantime, though, we have a contract copilot, which is essentially a conversational interface for the data contract. So you can start from there as well. If you have some specific requirements already in mind, and you can describe them, or maybe they're already written down somewhere, you can go into the UI here, open up the contract copilot, and paste those requirements into the chat, and it will go from those pieces of documentation of the requirements into actual executable data quality tests. So for example, I could say something like all right, let's say loan product ID should not be missing. So it can go from this statement of a requirement into an actual data quality check that can be executed. And it can be more than just one requirement. It can be many requirements, and really any changes that you can imagine you can make to the contract through this conversational interface. So it really accelerates the creation process and helps you scale up more quickly and get contracts on many data sets in a short amount of time. You can see that under the hood, though, there's actually a YAML file representing this contract. So this kind of unlocks other workflows and use cases where you want to really customize the data quality rules. You can even build these contracts programmatically if you want to. But you can see we have this kind of complete user interface for creating the data quality rules as well. So it can be fully customized. Even something as simple as a missing data check, you can define like what is missing or what threshold should I alert at. Any custom filters you want to apply, any custom properties, metadata properties or attributes you want to associate with it, all of that is possible. Then up here, we have got some general settings for our contract, like a general filter. Typically, this is going to be like a time-based filter. If we want to run this on a schedule, we just want to pick up the latest batch of data. We would use a filter up here for that. We can put some variables in here if we want to kind of parameterize our contract and make it dynamic. Um, we'll talk about the schedule in the next section. And then any metadata attributes that I want to associate with the contract, I can put them in here. And this is going to be useful for controlling the alerts to make sure the right people get notified about issues. But also, as we'll see later on, we can leverage these attributes when we create dashboards and visualizations about data quality. All right. So we talked about the contract language. Now, next, once we've created a contract, how do we run it? Well, the first and easiest way to run it is using the schedule feature here within the contract itself. Um, so there are many use cases where we just want to check up on the data quality on a regular schedule. And so for that, we can flip the switch here and define a schedule. We can also ask the Copilot to do it for us. We could say, for example, run this contract every Tuesday at 7 a.m. Eastern. It understands how to make that change. And so it put that schedule on this contract for me. So that's the easiest way to set it up to run. Once I click publish here, then that schedule becomes part of the contract definition. It's just going to orchestrate on its own according to that schedule. The other way that you can execute the contract is using our Python SDK or REST API, and you would do that from outside of Soda. So for example, maybe you have like an ETL pipeline or something. It could be in Databricks, could be in any other orchestration tool. So what you can do is you can insert some extra steps to the pipeline to run that data quality scan. So for example, here I'm like extracting some data. I can test it right away. Maybe I load the data into a table, then I can test it again, make some transformations, test it again. So this is the kind of typical pattern we see is doing something to data and then testing it to make sure that it's good. And then if and only if it's good, then proceed to the next step. So kind of being able to circuit break the pipeline if there's issues with the data and really trying to protect those downstream processes and consumers from ever getting the bad data. So for example, let's say we look into right here, we do some transformation and then we test the data after the transformation. So all our engineers working on this pipeline, all they need in order to run the data contract is the identifier for this contract. So that's actually the first line here in the contract is this path. So you have the data source name, the catalog or database name, the schema name, and the table or the view name. So if you have that information, then you can run that contract with just a single Python function from within your pipelines or your notebooks. And so this is my notebook. You can see how simple it is. I've got a widget here to parameterize that dataset identifier. So now this is essentially a reusable notebook. So no matter what dataset I want to run a contract for, I just use the same notebook and I'm just passing in that identifier for the dataset here. And then it's going to run the contract and give me the results here within Python. But we'll talk in the next section about what happens after we run the scan. All right. Scheduling. Now you can see here kind of how to trigger it with Python. Okay. So how to view the data quality results in Databricks. So for this, I want to talk first about this component called the diagnostics warehouse. So the diagnostics warehouse is essentially a dedicated schema within your Unity catalog or really any database of your choice, where all of the results for all of the data quality scans will be stored and organized automatically by SODA. So this is something that you configure when you first connect to Databricks through the UI. You'll configure this diagnostics warehouse component. And it's going to give that SOTA agent access to a specific schema where it's going to create tables, such as a table of scans. So every scan that runs, it will log it. What table did it apply to? When did it run? What were the results? For each scan, it's going to log all of the individual data quality rules that executed. What were the results of those rules and various other attributes? And then for many of those checks, if they're a record level check or a row level check, it's also going to log the individual rows that failed that specific rule. So this is great because that means that SOTA doesn't need to collect any information about failed rows and so on in our cloud environment, our cloud backend. All of that will stay securely within the customer's private system. But it's still providing that access to the failed rows, which is really important. So here's a little screenshot of that Unity catalog diagnostics warehouse. So the first use case that this empowers is drilling down to see those failed rows. So for example, if I have a specific data quality rule that's failing, like this one here, you can see it's kind of failing some days, passing other days. So if I click on this recent result where it's failing, there's 88 exceptions. I can see how many rows were tested, 30% failed. It's 88. Now, if I want to see those failed rows, again, SOTA is not going to collect them. We're not going to collect any of your actual data. All we collect is this kind of metadata of the results. So if you want to see the actual 88 rows that failed that rule, you need to go back to Databricks, and we make it easy to do that. So firstly, we generate for you some queries that you can run to see those results. So first is a query on the original source table or view, the source data set. And so this is essentially taking that data quality rule and inverting it to give us the exceptions. What we also have here are these frozen in time snapshots of exactly those rows that failed that check at that specific time. So if I take this query and run it, it's going to show me exactly those 88 rows. So really the difference between these is that this is a query on the original source table. So if I go and fix the problem and then I rerun this query, it's going to look like everything's good. But this one will always keep that frozen in time snapshot of the failures, which is useful for auditing purposes. So let's take this and go to Databricks and we can run it and see those failed rows. And this is typically something that's going to happen in the context of a workflow where, for example, you were assigned a ticket to investigate and resolve a specific data quality issue. So we're making that workflow simpler by providing you with those failed rows. So we can take that query, run it, and then here are the rows that failed that specific check. And we can see that they have application status as pending, which is not one of the valid values for us. Okay, so that's one use case for the diagnostics warehouse. Another use case is to embed data quality metrics within your dashboards, or even have entire dashboards dedicated to data quality to kind of have that bird's eye view and see how things are trending over time. So I built this dashboard here in Databricks, as you can see here. And all I had to do was create a dashboard and point it at all of those diagnostics tables that SOTA is automatically creating for me. So I don't have to go and create those tables manually or define a bunch of SQL to create those tables because that's just happening for me out of the box. So all I have to do if I want to is visualize it. And it doesn't have to be an entire dashboard dedicated to data quality. Instead, maybe you already have a dashboard for the actual data itself. If I wanted to, I could just add a widget to that specific dashboard just to show like the trust score for the data that's powering the dashboard, for example. Yeah, so here we can see kind of data quality trends over time. We can see some aggregate metrics to give us a quick glance of how things are performing. And here we can leverage those metadata attributes that I mentioned. If we wanted to kind of group by different segments, different attributes to see how data quality is performing in different aspects, like for example, different types of data quality, or any other attribute that we want to group by. And then here we can see, for example, like a summary of the latest scans. Another cool thing that we can do with SOTA is use this new Genie feature within Databricks. So we can point the Genie at all of those diagnostics tables, give it some instructions, as I did here. Let's see. I wrote out the system prompt, which I can share in the GitHub repo. But basically just telling it how to use these tables, what its purpose is, which is to provide updates or answer questions about data quality. But then once you've set that up nicely, Then you can just ask it for reports or updates about data quality. It can generate very comprehensive reports, including running those failed rows queries for you automatically. So you don't never have to manually grab them and execute them. It can just grab them for you from the diagnostics tables and execute them and show you those exceptions. So I think this could be really powerful, sort of vision for how to handle data quality in the future, which is just using these conversational interfaces to get quick reports and updates about data quality. And because it's grounded in real data, real diagnostics tables that SOTA is collecting, it has a really strong foundation and is kind of producing more trustworthy results as a result. All right. Genie. All right, so yeah, kind of went through that quickly. So this is a perfect opportunity, I think, for if there are any questions or any items from what I've discussed so far to like go back and double click on it, go dive deeper into anything. I'm happy to answer any questions or continue this conversation.
Tyler, there are two questions
Mhm.
about structured and unstructured data and one about data lineage. I don't know if you want to discuss it now or at the end of the call.
Now is good. Yeah.
Okay,
Um,
so the first
yeah.
question is from Tusif, and his
Mhm.
question is, does it also cover data lineage?
So SOTA does not cover data lineage. What we typically do is we integrate easily and seamlessly with our technology partners who do lineage, and that way we can leverage that lineage information as part of like the automatic generation or suggestion of data quality rules, or for even just tagging your rules and assets within SOTA, tagging them with the upstream or downstream relationships um, to help kind of organize the alerts and the reports about data quality. And what's the next question?
The next question is, how does SOTA handle the quality of semi-structured and unstructured data?
So we do support semi-structured data. So like for example, within Databricks, you may have like a struct type data type, which means that it's like has nested data within it. So that's something that we can support natively within our contracts language. You just need to put an expression that kind of says what is the subfield, the path to like the subfield that you want to put your test onto. So we can do that. As for unstructured data, that's not something that we focused on up until this point. So we can work with like text data. If you have text or strings like within your structured data table, we can work with that. You can have various tests on that data. Um, but kind of just a document like a PDF or a Word doc or something, that's not something that directly we can run tests on. Yeah.
Okay, thank
Questions?
you, Tyler. Third question, can a business user define a rule in Databricks using SOTA?
Yeah. So when you go into a data set like this, um, the easiest way, if I'm a business user and I've already got an idea for a rule, the easiest way is to leverage this contract copilot, describe the rule, like something like loan term must be greater than or must be at least 6 months and no more than 60 months. So I have some business rule or some requirement, and then I describe that to the copilot, and it's going to go in here and create that rule for me. So it finds the column that most closely matches what I've described here, loan term, and then it creates that rule for me. So that's one way. I think that's the easiest way to create the data quality rule. The other way would be to do it from scratch, kind of manually. So I could come in here, click add, choose what type of data quality rule I'm creating. In this case, it's a validity check. Um, and then I can give a name to it, like loan term should be valid. And then I could put like a valid min of 6 months, valid max of 60 months. And now I've created that rule. And then finally, you could do it this way, but probably a business user wouldn't mess around with the contracts language. Now, once you've created that rule, typically there's going to be a separation of kind of access or permissions within SOTA to ensure that a change like this or a proposed rule like this should first be reviewed before it can be published and put into production. And so what that flow would look like is let me first get rid of that one that I created. So let's say I'm proposing this new rule. So I won't see this publish button in that case. What I will see instead is this create a request button. So then I'll click this. I'll say new rule for loan term. Loan term should be at least 6 months and no more than 60 months. Okay. So I've created this request. This is like a pull request, but within Soda Cloud. Um, and I can mark this as ready for review. And now whoever we've configured to be the owners of this data set will be automatically notified that they should come in and review this new proposal for a new data quality rule on this asset that they're responsible for. Once they come in here, they can review it, they can propose alternatives, they can reject it. However, you can have that collaboration here within this requests interface. And then finally, you can mark it as done and publish the change. And now that becomes the latest version. You can see all the versions of the contract are controlled and stored here. So if you ever want to roll back to a previous version, you can do that. But you can see this latest version now includes that new rule that we created. Which means that, for example, if our engineering colleagues now want to execute this as part of their pipeline within Databricks, they don't need to make any changes. They don't have to update any files on their side because just simply using that identifier here for the data set is going to grab the latest version of the contract from Soda Cloud and execute it here. Any other questions?
Thank you, Tyler. Next question is there an option to import data contracts in ODCS format?
Yeah, so this is a interesting question, one that we've been getting more and more recently. We are working on a tool that's going to help you automatically translate from the ODCS format to the SOTA contract language. So I think we already have a prototype for that, but it will be released soon. I think even in the meantime, if you had access to SOTA Cloud, you could try with this Copilot here, just pasting in like your ODCS contract and see if it's able to do that translation.
Okay, thank you, Tyler. The next question is, can I join multiple data sets and apply a customized data quality rule on top of that?
Yeah, you definitely can. So I didn't talk about all the different kinds of checks you can create, but in addition to these kind of out-of-the-box check types, we also have just open-ended custom SQL checks. So those could be kind of a metric level, aggregate metric level checks, which are going to be, if you don't need individual row level results, you just need some metric and check on that. You could use the metric check. But if you want those custom or the kind of row level results, you would use a failed rows check here. And then it's just a query box here, and any query you put in, it's going to try to execute that query. And as long as it's a valid query for your data source, like in this case, Databricks, then it's going to work. And it's going to, whatever rows fall out of this query are going to be considered failed rows. So this is where you could have things like a join between multiple tables. I could say select star from table 1, left join table 2 on table 1.id equals table 2 something like this. Now I have this combined table 1, table 2, and I can have data quality rules applying to that. So that's one way that you can work with multiple tables. We also have some kind of out-of-the-box ways, depending on the kind of rule you're creating. So for example, let's say I've got this loan product ID column here. Now let's say I've got some reference table, a different table that has all the valid loan product IDs. Maybe there's only 1,000 or so of them. But I want to validate any loan product ID that shows up here in the finance loans tables. I want to validate it against that reference table. So what I can do that by going to invalid check here. And then instead of valid values, valid min, max, et cetera, you see there's lots of different kinds of validity. One of them is valid reference data. And so in this case, I could choose that reference table like loan products, and then validate this column here, loan product ID, against that reference table, which is like the ground truth for all the valid product IDs. And then finally, we have an entire section of checks down here, which are dedicated to multiple tables. So we call this reconciliation. It's really all about comparing two tables to each other. and having some rules about the difference between the tables. So in this case, we assume that our contract here is pointing at the target data set, but let's say maybe we have some source data set upstream that we want to compare it to. So what we can do is we can select that source data set. And here, the thing is, it could be in a completely different data source. It doesn't have to be in the same catalog. It doesn't even have to be in Databricks. It could be in like Postgres or something, some kind of source database. And I can select that table. Let's select one like this. And then I can define rules about the difference between the current target table and that source table. So if I want to compare the row counts, I can do that easily. Freshness, any aggregate metrics. And then here I can create a custom SQL expression or SQL query to compare the results of these two. And I can also even link up the two tables on some key columns and then compare them row by row and see if there's any differences in any of the columns values. So those are just some of the ways that you can create data quality rules that incorporate multiple tables. More questions?
Yes, thank you, Tyler. So the next question is, can the contract copilot also suggest automatic rule recommendations on a particular data set?
Yeah. So that's not the primary purpose of this thing, but it can do it to some extent. So if I say like, let me just close this out and refresh it. If I ask it to suggest some rules, it can do a decent job. Please suggest some DQ rules that are missing from my contract. So the thing is, this thing doesn't have access to all of the profiling information or sample data. So it's kind of limited just to the contract itself and high level metadata here, but it can still kind of, make some suggestions here. Like here, it's looking at the customer ID, making sure there's no missing customer IDs, making sure that IDs have no duplicates, assuming this is like the primary key. So it can suggest some basic technical data quality rules. This Copilot can. But one of the things that we're working on right now, we already have the MVP and we're releasing it, I think later this month, is this contract autopilot, which is kind of the next iteration of this Copilot. So rather than having you describe your data quality rules in natural language and then create the rules from that, it's going to just automatically look at profiling information, sample data, et cetera, and then suggest data quality rules directly using that information. Yeah, so this is, I think, probably more close to what you're thinking of with the automatic rule recommendations. All right. Next question. Is it possible to get table level DQ scores when multiple rules are applied with different checks? Table level aggregation DQ scores. Yeah, so whenever you you have a contract, you have one contract per data set, all of your data quality rules go into this contract. And then when you run the contract, which you can do like on the schedule or you can trigger it from your pipelines, then the results will firstly show up here. So you'll see like kind of this is like the overall passing rate of your tests for this specific data set. You'll see check coverage. You can see how many checks are passing and failing. You can also see that in this like dashboard view here in our UI. This is kind of even zooming out further away from just one data set and looking across multiple data sets. So there's that, so the results will definitely be stored here, like the high level metric results. And then, as I mentioned, you have that diagnostics warehouse, which is going to be in Unity Catalog. Let's see, like here I've got this schema dedicated to storing all the results. And so some of the results in here, let's see, we've got scans, we've got check results. So we can look to here to also see those results. And as I mentioned, you can visualize that in like a Databricks dashboard like this. I see it summarized over multiple checks. Any other questions? How can we bind data
Tyler, there
quality
is a
rules? Oh, sorry, Anton. I may be missing some. Go ahead.
yeah,
I'll let you
there is a
fill in.
question about the copilot. Just a general
Yeah.
question, like how does it work? And can customers bring their own models or API keys?
So bring your own keys is coming soon. This first iteration of it, we're just using OpenAI in the back end. The latest, greatest, GPT-5X, whatever. Um, but yeah, basically the Copilot, the way it works. Let's see. Let's go back to our data set here. So this thing, you can see what context it has access to. So Copilot is aware of this data set's column. So it has like column schema information. It knows column names. It knows their data types. It knows this is a Databricks table. So that way, if it generates SQL, it's going to be generating SQL that is valid for the specific dialect that's used by that data source type, Databricks. It knows about metadata attributes that are available within Soda Cloud. So it can kind of tag and document the contract with that extra context. And then, of course, it knows the message that you send it. So if I ask it a specific question or if I give it a requirement, it has access to that. And then finally, there's going to be a system prompt, some detailed system instructions that that our research team has developed and engineered specifically so that it gives good responses and makes these changes.
Okay, thank you, Tyler. And then
Mhm.
how can we bind the data quality rules for a particular project slash use case and run them in series or parallel?
Yeah, that's a good question. So, in terms of the first step is to define attributes which represent those projects or use cases. You can see these are fully customizable. These are just things that I came up with here. So things like data product, data domain, environment, importance. It could also be project, use case, responsible team, stakeholders, whatever metadata you can imagine. You can associate either the entire contract with those attributes or each individual check. So each check, I can come in here and tag it with a specific use case or project or whatever. So that's step one. And that means that whenever these checks run, I will be able to leverage the associated attributes to control who gets notified or also to kind of organize my dashboards and my reports. So for example, imagine something like this. I could break this down instead by project for something, or I could even just filter it to only show me metrics and results for my project that I'm interested in. So those attributes will be kind of persisted through into the diagnostics. Um, and then for the alerting, we have this concept of notification rules. So within the UI here, um, you can create a rule which says like, if those checks, let's say, have a specific project attribute associated with them, like a specific machine learning model or something, then notify these specific recipients. And that could be like a Slack channel, a Teams channel, a group of users. But that's a way that you make sure that you're getting alerts that are actually important and relevant to you. So leveraging those attributes is essential. Any other questions? These are great questions, by the way. I really appreciate all of these questions.
Thank you, Tyler. At the moment, those are all the questions. I don't know if there's any other attendees who would like to ask some more questions. Seems like we don't have any more questions, Tyler.
All right. Yeah, I'm just slowly going through the slides once more in case, there are some other things that come up, but I think we've gotten through, pretty much everything I wanted to discuss today. So, yeah, it's been a pleasure, and thank you again for all of your questions and for your time and your attention. And thank you, Raja, for joining and introducing us to Databricks. Um, as I mentioned at the beginning, we've recorded this, so we'll share the recording after the fact. And all of the examples and code and everything that I worked on, I'll put into this GitHub repository here, so you can take a look. And if you want to have a more custom or interactive demo with me or one of my colleagues, you can book a demo with our team using this QR code here. All right.
Thank you, Tyler. Do you still have time for another question?
Yeah, I still have time.
Okay, so we just got one other question. The question
Sure.
is, can we reuse the data quality rule?
Yeah, so you can reuse it. Yeah, you can pretty easily like copy and paste between the contracts to reuse the rule. And then I think probably more to your point is like, is there a way within the UI to just like create a rule once and then transmit it to many different data sets. And that's something that we're working on. It's going to come out soon. It's basically the idea of data standards. So that if you can have kind of organization level or domain level policies or rules that you then create the rule once and then choose the scope so that you can decide where it's going to be, which contracts it's going to be inserted into. So yeah, that's coming soon.
Okay, thank you, Tyler. I don't think we have any other questions.
All right.
Thank you, everybody.
Thanks again, everyone.